Okay, here's your second assessment on mixture problem solving. I have $30,000 to invest in two things: savings bonds and certificates of deposits. Savings bonds pay out 5% interest, while certificates of deposit pay out 7% interest. If I want to earn exactly $1,760 in interest, how much should I invest in each? Okay. So I'm going to need a chart here because I'm putting it in different percents. And on top, your lowest percent is 5%. Your highest percent, 7%. And there's not a third percent, so we write together. Okay, now you put percent in the middle and then find what your other values have as units. It's just dollars. You can see that. And now I'm set. Now let's look at the first row. This is all about dollars. Well, I see two dollar amounts, but neither one of them says 5% or 7%. Okay, so they're both together amounts. Put your highest here and your lowest down here, because that's after you take the percent out of the whole. And then this is X and Y, as always, because we're trying to figure out these two. Now you just rewrite your percents in decimal form. You just divide them by 100. 5%, 0.05, 7%, 0.07, and then NA. Okay, then you just multiply. 0.05x, 0.07y. And now I need to make a system of two equations. The top is simply x plus y equals 30,000. Now you don't want to write this one down unless you really want to be aggravated. You need to multiply these all by 100 so that the decimals, we won't have to worry about that. So 0.05 times 100 is 5x. 0.05 times 100 is 7y. And 1,076 times 100, 760 times 100 is 176,000. Okay, then you just do your multiplication. So you have 5. And the bottom's just the identity property because you're timesing by 1. So it's 5x plus 5y on top. 30,000 times 5 is 150,000. Remember to multiply that last one. The bottom, 5x plus 7y equals 176,000. Okay, now you make that negative. Remember, you're always adding. And then make your 7 negative and 176,000 negative. So you add 5 to negative 7, that's negative 2y. And you add 150,000 plus negative 176,000, that's negative 26,000. And then divide both sides by negative 2. That's going to be $13,000. That's your Y, 7%. Now, if you know that's 13,000, to find the X that goes with it, you just subtract 13,000, and that's 17,000. You shouldn't have to plug it into the system. You should know how to figure that out. Okay. All right, number 2. Manager of a store that specializes in selling tea decides to experiment with a new blend. She's going to mix Earl Grey tea, that's $5 per pound, with Orange Pekoe tea that sells for $3 per pound to get 100 pounds of the new blend. If all this is sold, they're going to make $450. How many pounds of each tea is required? Okay, so again, it's 3 units, but not with percents. So I go, my 2 units are Earl Grey, EG, Orange Pekoe, OP, then together. Okay, then we have how many and then per, and single. Then my third unit, dollars. Don't put that here, here, and here. Okay, find a number that's not money. 100, okay? 100 pounds. But it doesn't say that that's either one of those, because if you read it, 100 pounds of the new blend, that's together, okay? Then I can always go X and Y. Now 100's gone. Now find your dollars per. Well, $5 per, that's your Earl Grey. $3 per, that's your Orange Pekoe. And I don't really have anything else for per, so NA. So 5X, 3Y. What do I put here? Well, fortunately, the total cost is $450, so that goes right here. Okay. And now I write my system. X plus Y equals 100. And then 5X plus 3Y equals 450. Okay, so I multiply the tops by 5 and the bottoms by 1. So it's going to give you 5X plus 5Y equals 500. And the bottom's 5X plus 3Y equals 450. Now again, negative, and these both become negatives as well. So we add these together, that's 2Y. Add these together, and that's 50. And divide by 2, and that's 25. Okay, so that's your Orange Pekoe, 25 pounds of that. Now remember, together you have 100, so I could really just use common sense and subtract. 100 minus 25, 75. The one where it adds the more than, you are not going to see that on this. Okay, a coffee manufacturer sells cinnamon coffee for $7 per pound and vanilla coffee for $10 per pound. At the end of the month, the cinnamon coffee had 30 pounds remaining. The store manager decides to mix these 30 pounds with the vanilla coffee. He sells the mixture for $8.50 per pound. How many pounds of vanilla coffee should be mixed to ensure no change in revenue? So I got 3 units, no percents, so just set it up the old way. You got together, vanilla, cinnamon. How many per total? Okay, how many, again, that has nothing to do with money. Find a non-money amount, 30, okay? Read that sentence. At the end of the month, the cinnamon coffee had 30 pounds remaining, so that's cinnamon. And then this other 30 is just repeated information, okay? Cross them both out. So we don't know this. So over here, I write the expression X plus 30. And now I go on to my dollars per. Cinnamon coffee, $7. So you got per there. That's per unit. That's your cinnamon coffee. That's per unit. And that's your vanilla coffee. And this is per unit. That's when you mix them together. Okay. The mixture's somewhere in between. Okay. Then you just multiply on down to write an equation. So it's 10x. 30 times 7 is a constant, it's 210. And then here I parenthesize that expression and distribute. So it's going to be 850x. And I take 850 times 30, and that's 255. Okay, now write your equation. Remember, there's just one answer to this problem. Now your x's are on different sides. Don't add them, okay? Subtract. So it's 1.5. You're like, well, I thought you added them on this table. Not, yeah, when they're both over here, I do. Minus 210, minus 210, that's 45. And 40 divided by 1.5 is 30. Okay, so pounds of vanilla is 30. Okay, last one. In a chemistry class, you have a combination of 1% hydrochloric acid solution, 5% hydrochloric acid solution. You need 100 milliliters of a 3% hydrochloric acid solution. How much of each solution should you pour into the mix? So again, it's another percent problem. I use the same kind of table, but I label it differently. Take the lowest percent. Your highest percent is 5%. And then in the middle, you got 3%. Now, you know you got percent in the middle, and these two have the same label. Go find your number. The one that's not a percent, it says milliliters. So it's not money, obviously. It's ml. Okay, let's talk about this top row, the ml. Well, I have 100. It says it's 100 of a 3%. So I'm going to put 100 here, and then x, and then y. Then I write my percents. 1 divided by 100 is 0.01. It's not 0.1. Divide it by 100 on a calculator if you can't remember that. 0.05, 0.03. Then I just multiply. You're going to have 0.01x, 0.05y, and you're going to multiply these two values. It's just 3% of 100, which is 3. Okay, and write your system out. So you have x plus y equals 100. 0.01x plus 0.05y equals 3. Oh, shoot, don't write that down. Okay, multiply these by 100. So 0.01 times 100 is 1. Okay, so 1x. That's going to be 5y. 3 times 100 is 300. Now, I actually have something nice here. I don't need to multiply because I already have the same number in front of my x. I'm going to go negative because those would go away. Negative, negative. So that's going to be negative 4y equals negative 200. Then I divide by negative 4, and negative 200 divided by negative 4 is 50. Okay, so your y up there is 50. Actually, this is going to be a rare problem where they're both the same, okay? Because it's going to be 50-50. Doesn't always happen that way, but yeah.